Or just for the record, limits are a big topic when you get into calculus someday. Lots of things you can do with limits. We're just giving you kind of an introduction to it today. So I'm going to talk about what is a limit. There's all sorts of different ways to find or calculate limits. Today we're going to do off the tables and the graphs. I'm going to show you some algebraic ways and some sections coming at us in a minute. And of course you can have some limits you can't have an answer to. They don't exist, just is what it is. And then we're going to talk about what a one-sided limit is. Now, this is where I wish we had color copy machines. I know I say that all the time here. So take a look at the behavior. You got the graph up there, and they're going to give you a value. In this case, we're talking about 2. We just picked 2. Doesn't have to be 2, just pick a number. And we're taking a look at the table, of course, and we're taking a look at the graph as we get close to 2. So just some notation here we have to take a look at. So from the table, and you can see I got a little carried away on the decimal places. I'm going to show you how you can make your tables put that many decimal places if we want to see that. I'm looking at 2, and I'm looking at f of x, the y coordinates. I would say if I'm going to just kind of ballpark this, round this, approximate it, I would say as we're getting closer and closer to 2y or f of x, looks pretty darn close to 4 to me. Now, eventually, like I said, we want something a little more accurate than just looking at the table and kind of estimating it. That's going to be in some other sections coming at us. Today, when we look at the graphs, so when we are talking about 2, of course, we're talking about x. We want to look at from what we call the left side, of course. The left part of the graph, as we're getting close to it, approaches 4 here. And then, of course, as we look from the right side. So that's why mine are in red. I wish yours were in red. These arrows are important because we're going to talk about a left-sided limit and a right-sided limit. So here, of course, looking from the left, looking from the right, just for the record. Now, the limit of the function, this is just how you say this, and some notation here at the bottom, as x approaches 2 is 4. So really you're going to see this notation, obviously LIM stands for limit, the bottom, that arrow, x approaches 2. That's how you verbally say that or read that. That's what that arrow symbol means, approaches. So the limit as x approaches 2 of this function is 4. So a lot of what we're going to do today is like this. We're going to be looking at the graphs, looking at the tables. But you know I love to type on the calculator up here, so it's going to be really fun. Okay, so we write the limit just kind of like what we talked about. The limit f of x equals L as x approaches A. So that's exactly just what we talked about. L will be some sort of number. Ours was 4. Depends on the graph. Okay, so estimate the value of the limit by making a table of values. Check it with the graph. Now, pull up your calculators. Start in your y equals menu, start typing in this function. Now, I cheated because we know how slow I type on this thing. My y equals is going to look crazy because I have everything in there for today, so I have to watch me type all of these in. So type in the first one, and I like to use that horizontal fraction bar, which remember is alpha y equals, just so that I don't have to worry about putting parentheses around the numerator, denominator, and potentially screwing that up. So let me give you a minute. You just need to type the first one in. Like I said, I got carried away and did all of today's because I hate typing on this thing. So you get yours typed in. So what I'm taking a look at, of course, what value x is approaching. So we're approaching 1. So when I pull up my table, and we'll look at the graph in a minute too, when I pull up the table, I'm going to have it start at 1. So once you have that typed in, go to Table Setup, which is second window. And I just have something random in there from who knows what. So we're looking when we get close to 1. So that's going to be the first value I put in. Now, arrow down or enter. That little triangle symbol means how it's going to change your table. Normally we change it by the whole unit. 1, 2, 3, 4, 5, 6, 7. But I want to get a little more accurate. So it depends how carried away you want to get. I'm going to go 3 decimal places. So I'm going to put 0.001. So that's how it's going to change the table every time. So now when I hit second graph and pull up the table, we can see all our very lovely decimals. And obviously we can scroll. So I'm looking at the y coordinates. As I approach 1 from the left side, that looks pretty close to 0.5 to me if I had to call it. And if I approach 1 from the right side, looks like 0.5 to me, I would summarize this all as 0.5. Now, we're going to put, notice I didn't get crazy and gave you a bunch of rows in the table. We're not going to get too carried away, but I am going to put a few numbers in. So generally, for the table, I just start in the middle. 1, of course, you get an error. We're going to talk about that in a minute. So I just copied that off the table, and I'm going to put a few more numbers in here. 0.999, 503. So I'm just filling in stuff straight off the table here, nothing exciting. 0.998, 0.5. My sloppy handwriting, I should have made that a little bigger. And then I'm just going to put a couple more in. 1.0.498. So on and so forth. Now again, depending on, the 3 decimal places on the left is a little tough to fit on the table. If you wanted to do 2 decimal places, so just in your table setup, I'm going to start it so it hits back at 1, but I'm going to change this to 0.01. And there you can see it's doing it by 1 decimal place. Now, is there a hard and fast rule on how many decimal places you need? No. I like to do 3 because I find it, a little bit more accurate than 2. But I think we're all smart enough we can look at that and be like, oh yeah, y is about 0.5, okay? And again, we're going to find or show you some algebraic ways to get something a little more exact. Why is there a question for you? Why is there an error at 1?
Because 1 can't approach 1. Because it is 1. Can't be 0 on the bottom.
Can't be 0 on the bottom. If you put 1 in here, 1 squared minus 1, 0, 0 under the line, undefined. Now, just because I know it's coming ahead of us, 0 underline undefined, that would be a vertical asymptote. We talked about vertical asymptotes way back in the day. There is a relationship to limits on those. If you want, of course, too, you can take a look at what the graph looks like. So as we're approaching 1, I don't care about this bottom piece because I'm looking at when x is 1. So when I'm approaching that, I can't Hail Mary that and tell you that's 0.5 from looking at the graph. Couldn't tell you that. I don't know if you know this feature on your calculator. If you hit trace, that will keep your cursor on the graph. It won't go all over the place now. So as I'm cursoring, as I'm getting closer to 1, I'm watching y. 0.7, getting closer. Yeah, that looks about 0.5, so on and so forth. So that will keep your cursor on your graph too, just to kind of show you that. Don't know how good, all that good stuff with our calculators there. Okay, find the limit from the table. So same thing. I'm going to, in your y equals, and like I said, I cheated and typed mine in earlier. So I'm just going to go over and turn this one off, turn the one underneath it on. And notice I just used x for the variable instead of t. So you can too. So get that one typed in. I used x instead of t. The variable doesn't matter. And again, I'm going to go to my table setup. Now we're looking at t approaches 0. So I'm going to, on my table setup, I'm going to start at 0. Again, no hard and fast rule on how many decimal places. I like to do 3. I just think that's more accurate, but whatever. Let's start here at 0. And I'm going to do 0.001. Have a change. And take a look at the table here. Of course, we've got the error message there. Well, I'd say we're pretty, if I got a ballpark it, 0.1667. This is kind of what we have on the y. Now, of course, we get a lot of similar stuff there. If you scroll, pretty consistent. I would have to change how many decimal places if I want to see anything else because it's rounding it all to the 7 on that last decimal place. For our purposes, we're just estimating that. So first I'm going to just jot down the 0.167. I forgot a 6, 0.1667, there we go. Just for fun, and the love of math, do we know approximately what fraction that, exact fraction that equals?
1600s. Wait.
It was right on the tip of our tongues, right? All right. Notice no table for you to fill in this time. We're just looking at the table and estimating. Now, we can have limits, of course, that don't exist. And again, same thing, just to pick on Grayson here, he pointed out last time, of course, when you had 0 on your table, you had that error message, 0 squared on the bottom, 0 undefined, same thing, vertical asymptote, blah, blah, blah. All of that is going to tie together. Now, We can have answers, as we know in the world of math, that don't exist. We can have limits that you cannot find a pattern, a consistent pattern, say, yeah, that's about 0.5. So that's one we're going to kind of talk about here in a second. So functions do not necessarily approach a finite value at every point. In other words, it is possible for your limit not to exist. That's what the next few problems are going to show us. So this Heaviside function, now I don't know why some random thing I know this, it's named after some electrical engineer in case you wanted to know that. Find the limit, sketch a graph. Now, here's why I'm going to sketch a graph on this. How am I going to put all of that shenanigans, I mean, yeah, I can use x instead of t, clearly, into my y equals menu and take a look at it. Could I do it? Yeah, but I think it's more obnoxious than if I were just to graph it, sketch a graph, and look at it myself. So just on the side, we're not going to get carried away here. Notice, of course, instead of x and y, they have t and h of t. Now, just to power the smartboard, I'm going to color code mine. So h of t equals 0. Or we're used to y equals 0. What type of special line is y equals 0? Vertical or horizontal? Horizontal. Horizontal. Now, but, I'm not going to draw, I mean, 0 is kind of hard to see on the axes. I'm not going to draw it all the way across, though, the whole x-axis, because I only want where it's less than 0. So I'm going to start here at 0. Less than is going to be an open circle, less than to the left. So that would be the top function. I know it's kind of hard to see when it's on the x-axis, too. Okay, bottom one I'm going to do in blue. Now, I need to throw 1 on here. And of course, equal to 1, so, or equal to 0, so I'm going to put my closed circle on it. And greater than, so I'm on the right side. Pretend I drew that straight. Got away from me a little bit, but it could be better, it could be worse. So here's the thing. It says find the limit, in this part, when it approaches 0. And I'm like, If I approach 0 from the left side, so I'm looking at the green. As I approach from the left side, I would say the limit would be 0. If I approach from the right side, though, I'm going to say the limit is 1. So because you're approaching different values, 0 from the left, 1 from the right, it doesn't exist. We have to approach the same value from both sides to have a limit that exists. This function is what we call a jump. You got the jumps between them, so you're not going to have a limit. It does not exist. And of course, you can abbreviate D and E. If you like that. Okay. Now, can you graph this on your calculator? Sure. But your calculator will not do the constraints for you. The t is less than 0. The t is greater than or equal to 0. It will put the 2 horizontal lines on there for you, but you're going to have to know what parts to look at. Personally, I think it was quicker for me to just sketch that hand. Okay, let's take a look at this one. So we're going to do it on the table. Now, we got to talk about our mode here for a quick second.
Oh.
Love the enthusiasm. Our mode needs to be in radians. Why?
I don't know.
Because it's pi. Pi is in radians, not degrees. So I don't know what my calculator is in degrees, so I'm going to switch mine here too. I'm going to get my y equals, and like I said, I kind of cheated and typed these in earlier just because, you know, I hate typing on this thing. So I'm just going to turn on my third one here. We're going to look, what are we approaching 0? So get it typed in, of course. You probably have a nice clean y equals menu. I just put them all in for little sake of typing here. Now, we're looking at, of course, I'm looking at my problem as x approaches 0. Notice I didn't make it fill in too many values on the table. So I'm going to go into my table setup. I'm going to start at 0. And then again, it's really your choice how you want the table to increase. I usually like to do 3 decimal places for the thrill of accuracy. Let's take a look. I can always adjust it. Oh. Hey. Whoa. Hey. We have a truckload of different things happening in the y column, agree?
Yeah, what is happening?
So are we approaching a consistent number from the left and the right? No, does not exist.
So we don't have to fill in the table?
Fill in a few numbers on the table. There's my table. Power the smartboard. Yay, winning for me. to get crazy, just fill in a handful. And of course, let's see what the graph looks like just for fun. Oh! I'm looking at that graph in the middle, and I'm like, holy enchilada. That's, I mean, oscillating. It's going up and down. It's going between 1 and -1 there. So that is why we don't have our limit.
Well, that's what I'm doing.
It looks like it kind of had a stroke or something there. I'm not quite sure. Okay.
Looks like a nasty curveball.
Oh boy. All right. Find this one, of course. Now notice I didn't make you fill in the table. We can do it on our calculator. So here we go. Here we go. Fill it in on your calculator. Click on over here. And of course, I typed it in earlier, you know, my last one here. So get yours typed in. That's an easy one to type in. Now this time I'm going to, just to mix it up, I'm going to do a little backwards on you. I'm going to look at the graph first just to kind of see what's happening as we're approaching 0. I don't know if I love that, quite frankly. But let's look at the table. So I'm going to start at 0. And we keep the 3 decimals. Remember the E means times 10.
Times 10.
Would you say, look at the Y's. Are we approaching a consistent value? No, I mean, we got a lot of large numbers and stuff happening there, but we're not approaching a consistent number like 0.5 or whatever the case may be.
So DNA.
DNA.
That's it.
DNA.
Now, also notice, again, just tying it together because I know this is coming at us. I keep talking about vertical asymptotes. Look at the graph. Your vertical asymptote would be right here in the middle. X equals 0. Remember, vertical asymptote line you cannot cross or touch. So we're going to get into that a little bit here coming up in another section and how that relates to your limits. That does make a difference. All right, so one-sided limits here we're going to talk about. We've kind of already been talking about it a little bit. So of course this is where we're talking about where they jump. So that one where we had the 2 horizontal pieces, the one-sided approach 0, the other side 1. So that's what we're talking about, one-sided limits. These are the tiniest symbols, but hopefully you can see that little negative there and the positive. So with the negative, I think of that obviously as your left side, negative to the left, less than 0 to the left. And then of course the plus, you're looking on the right side, greater than 0. So it's kind of separating it out into the left side versus the right side. So just like when we go back to that, full screen it here, well, let me find it. This guy, the green would be my left-sided limit, the red would be the right-sided limit. Now, next thing I'm going to show you though, for the overall limit to exist, they have to equal the same number. This still would be, it does not exist, but I could tell you the left-sided limit is 0, the right-sided limit is 1. So there are one-sided limits, but the overall limit does not exist because they equal different values. So that is really what all of this does to you that I just rambled on about. So again, if you take a look at this, you've got the little tiny negative here and the positive. For the overall limit to exist, the negative, the left, and the right have to be the same value. If they're different, the overall limit still doesn't exist, just for the record. So lovely graph, okay? So g of x is our function over there, both curves considered together. So the negative, of course, I just think of that as the left-sided. And I'm looking at 2 here. So I like to zero in on the 2. So as I approach from the left, bam, I would say the limit there is, what's your y value? 3. So this is what we're looking at, okay? When I look at the plus, or what I like to think of it as the right. So from this side, so I'm looking at this guy from the right. I don't love that. What does it approach from the right side? What would you say your limit is? 1. Question now. Do you have a limit when you approach 2? No, because we have different answers. 3 from the left, 1 from the right. So this answer is the big DNE. We did have the individual or the separate left and right limits, but we don't have the overall. Okay, let me erase all my drawing here because we're switching now to 5. Same deal, same deal. Focusing on the 5 here. Okay, from the left. That's the negative, of course, left. From the left. Okay, as I approach from the left, what would you say y is? So I'm approaching from the left, I get close to 5. Y is 2, close to 2, right? Okay, now I'm approaching from the right side. Right side, as I'm approaching, I'm getting close to 5. I'm looking right there. From the right side, 2. So what would you say your overall limit is? 2. Because they equal the same thing. Just for the record. So left, right. Know your left and right. We got that. Okay, last thing we're going to do, but we're going to draw one from scratch, because why not? Let's draw a graph. Plus it gives me a time to, review piecewise functions. Why not? Okay. Let it be a function, blah, blah, blah. Now, here's the thing. Can you use your graphing calculator to help you sketch these? Sure. Weak, though. Weak. I'm going to do it from scratch. I'm going to do the top one in red. Okay. So, I'm not going to get crazy here. I'm just going to make a couple points, make it happen. Obviously, 2x squared is a parabola. The vertex would be at 0, 0. And I'm just going to do a little mental t-chart. Can you type in your y equals calculator, y equals 2x squared, and get the t-chart? Yeah, but we don't need to do that. Okay, notice, less than 1. So I'm going to start at 1. If I put 1 in here, what's 1 squared? Times 2. So 1, 2, but I'm not going to put a filled in dot there because on the inequality you have just a less than. So that would be a little open circle, which is hard for me to draw on the smartboard, but work with it. If I put negative 1 in for x, what's negative 1 squared times 2? 2. I'm going to put one more number, and I'm not going to get crazy here. Let's put negative 2 in. What's negative 2 squared times 2? 8. And I'd probably be off the graph if I tried anything else. Okay, I'm going to do the bottom one in green. Feeling Christmas colors today, I guess. Now, the bottom one is super easy because, of course, that's in your slope-intercept forming. Really, x should be first, but I think we can handle that. Our slope's negative 1, y-intercept 4. So I'm going to mark it out, but again, I'm only going to bold in a piece of the line. Y-intercept 4, unit, slope negative 1. Downward right. Okay, so there's kind of a template of my line, of course. Now, we only want the portion of the line where it equals 1 and to the right. So 1 right here is going to be right here. Bolded and circle. Pretend I'm going to draw this straight. There it is. So get your, and again, you can use your calculator to help you, but we should be able to do that by hand. Okay, look closely, and I know they're tiny, hopefully you have a good vision. Look closely, you got the negative, so left. So remember, we're approaching 1. I'm going to mark it there on the graph grid. As I approach 1 from the left, y would be, what would you say? As we approach it from the left, y is 2. As I approach 1 from the right, it's 3.
Alex.
Which means, God help us out. What is your final answer now?
Does not exist.
Got it.
I get this.
All right. Any questions on doing your limits from the graph? I love this stuff. Okay, let me grab your homework.